This video is looking at the different types of word problems that we will see in the lesson that is entitled Mixture and Interest Problems. So we're going to go through a few examples to help you along the way. So the first example says, what is the sale price of an item that is on sale for 20% off the regular price of $150? So 20% off of the regular price of $150. So when they ask for the sale price, this one ends up involving two steps. We have to figure out what is that percentage, the amount that they're taking off of the sale, off of the regular amount, and then subtracting those two amounts so we know how much we're actually going to pay. So in order to find a percentage of an amount, we have to take that and multiply it. But when we look at percentages, we don't actually use percents, we change it to a decimal. So 20% becomes 0.20 because we divide it by 100. Percent means per 100. And we figure out what this amount is. And in this case, we can do this by hand, or you can use a calculator. And what we find out is that this is equal to 30. So that's how much is getting taken off. So when they say it's 20% off, that means they're going to take $30 off of this, the original price. And so to find the sale price, we need to subtract those. So 150 minus 30, again, can do it in our head, do it by hand, or use your calculator. But we get $120. All right, let's look at the next example. This one says the temperature dropped from 80 degrees to 60 degrees. So 80 degrees down to 60 degrees. What is the percent decrease? So we're looking for the percent decrease. All right, so percent decrease means that we want to find a percentage, so our answer will have a percent sign. And how do we find that? So anytime we're looking for a percent decrease or percent increase, it kind of follows the same pattern. So our first step is to have the difference between the two items, in this case temperatures. So we're going to do 80 minus 60. And then we just divide it by the original, so whatever that happens to be. So in this case, when it says it dropped from 80 degrees to 60 degrees, that means 80 was the start. And then we keep going. So on the top, we need to subtract first. So 80 minus 60 is 20. And then we can do 20 divided by 80. Again, calculator is totally fine in this case. So 20 divided by 80 gives us 0.25, and then we have to change that to a percent, so we multiply that by 100. 0.25 times 100, and so it is 25%. So in this case, when the temperature drops from 80 to 60 degrees, it's a 25% decrease in temperature. Let's look at another example. A person earns $460 in interest in 1 year at 7%. So $460 earned in interest in 1 year at 7%. What was the amount of money invested? So sometimes in our problems we have to use a formula. In this case, because we have interest and years and percents, we need to use our interest formula, and that one is I equals PRT. And so I stands for interest, P stands for principal. So principal is the amount of money that was put in at the start. In this case, that's what we're looking for because it says what was the amount of money invested. R stands for rate, so interest rate, but we have to always use a decimal. And T is for time, and time is always in terms of years. So let's plug in what we actually have and where it goes. So $460 in interest. So that's our I. And we don't know P. Our interest rate is 7%, so that's 0.07. And our time is 1 year. And 0.07 times 1 is 0.07. So I'm just going to rearrange this to look a little different. 0.07p. And now it's just an equation that we need to solve. So we're going to solve for the variable. And so we need to divide both sides by 0.07. And so we need to take 460 divided by 0.07. And that gives us, so that's 1, so we get P equals, and we'll have to round it, just depending. So it's 6,571.43. So that's $6,571.43. So that's how much money was put into the account in order to give $460 in interest after a year. Okay, last example that we're going to look at today. This one is a mixture type problem. So let's see what we have. Chocolates costing $8 per pound are to be mixed with chocolates costing $3 per pound to make a 20-pound mixture. If the mixture is to sell for $5 per pound, how many pounds of each chocolate should be used? Okay, a lot of words there. So we know that we have some sort of chocolates that costs $8 per pound. And then we have some other chocolates, so they're not the same. And those sell for $3 per pound. And what we want, so we want a 20-pound mixture of chocolates. So that means we're going to take the two groups and mix them together. If the mixture is to sell for $5 per pound, so this right here, we're going to sell it for $5 per pound. Then we need to know how many pounds of each of these chocolates we need to buy. Okay? So we just don't know how many pounds of each of these, right? We just don't know. Okay, now that we have this information, we can make a chart using all of this because there's a lot of pieces to it. So a chart is sometimes helpful in these situations. So the chart would be like pounds of chocolate. And then we would have cost per pound. LB is the technical way to talk about pounds. And then the total cost. All right, and now we have a nice, beautiful chart. So let's think about what we were given. It says we have chocolates cost $8 per pound. So we have some sort of chocolates that cost $8 per pound. We don't know how many pounds, so we give it a name like X. Okay? Then we have some other chocolates that cost $3 per pound. Again, we don't know how many pounds it is. However, we have a clue. We don't want to have two different variables because then we can't solve it. So what we do know is that we want the total mixture to be 20 pounds. So if I'm taking both of these pounds of chocolate, however much they are, and I stick them into a bowl, then I'm going to have a total of 20 pounds. So this one that we don't know, since we named one X, we know we want 20. So this guy is going to be 20 minus X. So it's the difference between them. Now, how do we work this lovely chart? Oh wait, we have one more piece of information. The mixture is going to sell for $5 per pound. Okay, so how do I fill out the rest? Well, we multiply going straight across to get that last one. So, x times 8 is 8x. Then this one is 3 times that quantity. So 3 times 20 minus x. And then 20 times 5 is 100. Now, okay, we filled out the chart. Cool. Where do we get equations? Because we can solve equations. So, where does that come from? Well, it comes from going down in the columns on the outsides. So notice in our pounds column, if I add those up, they will become 20. If I had x plus 20 minus x, I would get 20. So the same thing applies for our total cost. We add going down. So our equation becomes 8x plus 3 times 20 minus x equals 100. Now we have an equation we can solve. So let's get some room here so we can actually solve this. So let me rewrite that. 8x plus 3 times 20 minus x equals 100. Okay, so now we need to distribute the 3. So we have 8x plus 3 times 20 is 60. 3 times x is 3x. And now we want to combine some like terms that are there. So these two are alike. 8x minus 3x is 5x. And now we can actually solve. So we're going to subtract 60 from both sides. And we get 5x equals 40. Divide both sides by 5. X equals 8. 8 what? 8 pounds. So remember on our chart, the one that we said was X was related to the $8 per pound. So we need 8 pounds of the chocolate that's going to cost $8 per pound. Okay. How do I find out how much the other chocolate was? Well, if we also remember that in our chart, the other chocolate, the chocolate that costs $3 per pound, we said that the poundage was 20 minus x. So we plug in 8 because 8 was x. So if we do 20 minus 8, that means we get 12 pounds of chocolate that costs the $3 per pound. Right, that's it for this video. Now you'll just need to give me a call so we can discuss this video and answer any questions that you have, and you can work on the assignment that follows. Have a great day.